O-Level Biology 5090, paper 4-1, May, June 2024, and question number 1. So question number 1 is respiration, which release energy from food in living organisms, can be summarized by the following equation. It shows the aerobic respiration, that is the glucose and oxygen. They will react together to give carbon dioxide and water. A student investigated the rate at which oxygen was used for respiration by some small animals. The apparatus shown in figure 1.1 was used. The apparatus was sealed by closing the clip so that any changes in the volume of gases in the test tube and capillary tube resulted in the drop of colored liquid moving. The rate at which the drop of colored liquid moves is related to the rate of uptake of oxygen by the small animal. So the apparatus which was set for this experiment, that is shown on the figure, that a test tube has been shown, which has a chemical at the base which will absorb the carbon dioxide. It can be sodium hydroxide or potassium hydroxide. Wire gas, or which is made up of zinc, is there, on which the small animals are kept. Small glass tubing which is closed at the top with the help of a clip. Capillary tube is there, in which the drop of colored liquid will move, and scale has been shown to calculate the movement of the drop. Now the question is, according to this apparatus, when the small animals in the test tube respire, they take in oxygen and produce carbon dioxide. You know, the process, during the process of respiration, the oxygen is taken in and carbon dioxide is removed. But in this apparatus, they have asked that describe what happens to the carbon dioxide they produce. So in this apparatus, because you can see that chemical is present at the base of this test tube, so the carbon dioxide which was released by these animals as a result of respiration, it will be absorbed by the chemical. So it will be absorbed by chemicals. So there will be no carbon dioxide in the apparatus. Explain why the drop of colored liquid moves along the capillary tube towards the small animals. As you know, the during the process of respiration, when carbon dioxide is released and oxygen is taken in, when oxygen is taken in, and in that case, the colored liquid drop will move towards the animals because the animals are using up that oxygen. Now we will move towards the next question. And next question is part B, in which they have asked, at the start the investigation, the student read and recorded the starting position of the drop of colored liquid against the scale. Then readings were taken every 10 minutes for 40 minutes. All readings were taken at the left side of the drop. Figure 1.2 shows the position of the drop at the start and after 40 minutes. Complete table 1.1 by inserting these readings. You can see at the start and at the end after 40 minutes. You can see the reading at the start of this experiment. It is more than one, which is we can count 1, 2, 3. So it can be 1.3. So let me move little bit for this. So you can see that the reading which was at the start, it is 1.3. So it is 1.3, and the reading at the end of the experiment after 40 minutes, it was 5, 6, 7, 5.1, 2, 3, 4, 5, 6. So it is about 5.6. So these are the two readings. At 0, at the start of the experiment, it was 1.3, but at the end of this experiment, it was after 40 minutes, it was 5.6. Now we are moving towards the next question, which is about the graph. And question is, Construct a graph of the data in the complete table 1.1 on the grid below. Uh, you can see that join your points with ruled straight lines. So you can see I have drawn this graph. On x-axis, time was an independent value, and whereas the position of the drop was dependent value on the time. So I have taken the time on the x-axis and position of the drop is taken on the y-axis. So in this way, the first value, which was between at 0 time, it was 1.3. So it was this value. And then at 10, it was 2.5. And then at 20 minutes, it was 3.9. And at 30 minutes, it is 4.2. And at 40 minutes, it is 5.6. So all these values are kept in this or drawn on in this graph. And according to this graph, you can see we are moving towards the next graph because it has been done. And the question about this graph is use your graph to estimate the position of the drop at 25 minutes. So they have drawn at 0, 40, 10, 20, 30, and 40 minutes. So they have asked now find out the position of the drop at 25 minutes. So at 25 minutes, you can see we have done this in this way. So it will be between 20 and 30 minutes. So at 25 minutes, I have drawn this dotted line. So this dotted line shows the value, which is 4.05. So this dotted line will show the which is 4.05. Now, next question is calculate the distance moved by the drop during the investigation. The final reading was 5.6 and the start, it was started at 1.2. So 5.6 minus 1.3 is equal to 4.3. And then calculate the rate of movement of the drop during the investigation in centimeter per minute. So we have to find out in per minute. So movement of the drop in 40 minutes, it is 4.3 centimeter. So what will be in 1 minute? So according to this, 4.3 will be divided by 40 and answer will be 0. So answer will be 0.1075 centimeter per minute. So it was all about this graph, the questions, different questions which were taken about this graph. Now, next question is, suggest why the student should repeat the investigation several times. Students, whenever we do an experiment, we always repeat it again and again to get the correct values, So in this way, there is no chance of mistake. So we can say that the results can be more reliable in this way to make results more reliable. There will be no chance of any mistake. Just suggest a control experiment for this investigation. And control experiments, we can say that we can remove the animals. Apparatus will be set as it is in the diagram, but there will be no animals. So it was all about question number 1. Please like, share, and subscribe my channel. And thanks for watching.